Welcome back to our C# beginner tutorial. In the previous lesson, I think we looked at enumerations. In this lesson, we're going to look at interfaces. Let me bring up Notepad. So interfaces is spelled like this. Interfaces, interfaces. So what are interfaces? The very simple definition I can think of is an interface is a specification of methods. It's a specification of methods which, when implemented by a class, mandates that class to provide implementation of those methods. Okay, so an interface is a specification of a collection of methods. I know this might not make much sense, but we'll see what that means. The whole theory we're writing here, we'll try and explain that. Okay, so an interface is a specification of methods which, when implemented mandates, implemented by a class, mandates that class, so it becomes obligatory for that implementing class to provide mandates that class to provide that's not the spelling of implementations of those specified methods. Okay, so what this whole grammar is saying is that basically an interface is just a collection of declared methods. Okay, I'm trying to make this official. Well, I wouldn't call it official definition. It's just me trying to explain what an interface is, or trying to define what an interface is. So I want to make, I think it's a bit kind of complex. I want to make it simpler. So an interface is just a collection of declared methods. Okay. I think the only thing that might give you that you might not know is declared methods. I know we've treated methods. You know what methods are. So a collection of methods. However, for an interface, they are declared methods. Okay. Now, what are declared methods? Declared methods are just methods that have been declared without any implementation. Okay. So let's see an example. So you remember how we usually create methods. So for example, suppose we have a void method that displays something like, say, public void. So this is how we usually create our method. We say public void, let's say display, for example. Suppose this display is a method, okay, and it takes no arguments. So this is how we usually write the method, and then we open curly brackets, and in between the open and closing curly brackets, this is where we usually write the code to implement the method. Okay, to implement the method. Okay, so everything we're going to write in here. So we're going to write So we just write some code here in between these two curly brackets. Okay, these two curly brackets. And the code we write in here is known as the implementation of this method. Okay, this is, I know I said this is the signature, that it contains the signature of a method, contains the access modifier, the return type, the identifier of the method, and then the arguments. Okay, that's the signature of the method. Also, at the same time, this signature of this method declares that method. Okay, So usually a method has a declaration part and the implementation part. Okay, so this is the implementation of the method, and this is the declaration of the method. Okay, now in I think we should probably open up Visual Studio and see a practical example of how an interface is created. Okay, or we see an example of an interface, so we know what. For that, I'm going to create a completely new project. I'm going to call it Interfaces Basics, and I'll make it a console application, and I choose next. I'll call it oh, sorry, this is where I'm supposed to provide the name. So interfaces basics, and I'll go to my desktop. Okay, we're already on desktop, so I'll create a folder here where we usually keep our projects, and I'll call it interfaces basics, and we'll select that folder. Okay, all right, and then we click on create to create the solution and the project for us. Okay, why? Gosh, I chose Visual Basic. Okay, let's go back and create. So I'm going to I'll just exit. Nope, I'll just create a new if I choose new project, it's going to create it inside this solution. So I'll just exit. Okay, I'll start it from beginning. I think I accidentally chose Visual Basic instead of Visual C#. Okay, so I'm going to choose create new project. I'll choose console app, and are we on Visual C#? This is console app. Okay, how do I know if I'm? Oh, okay, here it is. So I'm on C#. Okay, so that's good. I'll select that and click next, and then choose the name interfaces basics, and I'll choose. I think I'll just put it in the same folder that we created. Okay, and I'll choose create, and then it creates the solution for us. Okay, okay, that's much better. So we're now using C#. Okay, this is the main program. I'll just remove that console.writeLine. So execution starts here. Okay, okay. Now the first thing I'm going to do is I'm going to create an interface. Okay, watch and notice how we create an interface. It's a very similar procedure to the way you create a class. Okay, also an interface can reside in its own source file, just like a class if you like. Alternatively, you can put your interface or interfaces in the same source file as other classes or as other types that you create. Okay, so just for convention's sake, I'm going to create the interface in its own source file. Okay, so if you remember the way we create classes, we usually go to project and then choose add class. Okay, now for this one, we could still use add class, and at the end of the day, it's going to give us an option to select whether we actually want a class or we want an interface. Okay, but a better way I think to do it is just to select add new item. Okay, so I'm going to click add new item, and this is what I was talking about. So even if we had selected add class, it still brings us up to this particular dialog box. Okay, so we still have the option to select whether we actually want a class or we want an interface or other different items. Okay, so I'm going to choose an interface. Okay, and then down here, just like the source file for our class, I'm going to name the name of the source file the same name as the name of the interface. Of course, this is not mandatory. Okay, it's just convention's sake. So the interface I'm going to create is I'm going to create an iFlyable. Okay, so I'm going to call it iFlyable. Okay, so it's I capital F. By the way, it's capital I capital F Lyable. Okay, and then I'm going to choose add. Okay, so if you look to your right hand side, you will see that you have another source file, iflyable.cs. Okay, now if you click on that triangle, notice the difference between the icons of an interface and the icon of a class. This is the icon of a class. Okay, notice the difference. An interface has this thing that looks like a key. To me, it looks like a key anyway, but a class has this kind of I don't know what's that. Anyway, you can see the difference in the icons. Okay, so this is the icon that signifies Visual Studio recognizes this program as a class, and it recognizes this iFlyable as an interface. Okay, so let's go back to our interface, iFlyable interface. Notice how it is created. Okay, so it's written interface, and then just like a class, you remember if you want to create a class, you write class, and then by the way, I said we should always make our classes public. Same with interface, always make them public. I'm not sure there's any reason why you would want your interface to be private. I doubt that, but it's not like it's absolutely necessary to make it public. But I just don't think of, I can't think of an a situation where you would need an interface or a class to be private. Okay, just keep them public. Okay, for simplicity's sake. Okay, so this is how you create your interface. You write public, then the interface keyword in. Notice that the interface here is small I is a keyword. Notice every keyword is written in color blue, just like public is a keyword. It's written in blue. Namespace is a keyword. Using is a keyword. Interface is a keyword. Did I mention that in the names of your identifiers, you cannot name your identifier the same name as a keyword in C#? I think I did not mention that. So you should take note of that now. Okay. So what that means is I cannot create, suppose this interface, I can't call it interface with small I. Okay. Because interface is a keyword. I cannot name an identifier the same name as the name of a keyword. Or I can't call this, I can't call this class. Okay. All these are reserved keywords. Okay, let's take it back to our iFlyable. Okay, so basically, like I told you in the definition, an interface is just a collection of declared methods. Okay, so this is how it's going to look like. Inside, I'm just going to declare one method for this interface. Notice that an interface, it doesn't really it's not always necessary that you only need one, or you must have only one declared method in an interface. That's not true. You can have as many declared methods as you like. Okay, it's just like an interface is like a contract. Anyway, let's just finish up, and I'll explain later. Also, the members of your interface, that's the declared methods of your interface, they must be public. Okay, that's another thing you should take note of. They must be public. Now, you cannot have a private method, a declared method in your interface. That will not work. By the way, let's try that and see. So let's call this method fly void. It's going to be a void method, and we'll call it fly. Okay, and we put a semicolon. Now this is how, anyway, let's finish with the private. Now the reason why this is not working, it's underlining it in red, is because of we're making it private. Notice what it's saying. iFlyable.fly must declare a body because it is not marked abstract, extern, or partial. Private member iFlyable.fly is unused. Okay, basically what it's saying is that if I'm going to create a private method in the iFlyable, in the iFlyable interface, I have to provide implementation of it right in here, which I'm surprised it's telling me this. I used to think that you cannot have a private member or a private method. So let me just test that and see if that works. Actually, this is something new I'm just learning now. I don't know if this was included in the new C#, but I used to think you cannot have private members in an interface. So this is an eye-opener for me. This is something new I just learned today. Anyway, okay, so that's something you should keep in mind, that you can have private members. I think this is going to open up a whole door of different complications to my code if I'm going to. Anyway, for me, really I haven't been doing this, so I really can't think of a reason why I would need a private method in an interface. I'm not sure. There must be a reason for them to have allowed it. There must be a reason, okay? Believe me when I say the development team in C# are very, very intelligent group of people. So I'm pretty sure there's a reason why they have allowed you to create private methods that you can implement within an interface, okay? So for now, as a beginner, I would advise you to just stick to declaring public methods, okay, in your interfaces. So I'm going to create public void. It's going to be a void method, and it's going to be called fly. And then after the open bracket and the closing bracket, I'll just put a semicolon. Now notice the difference. This is a method. This fly is a method, okay? But notice I'm using a semicolon as if this is a method call, right? But this is just a declaration. So this is how you usually declare a method, okay? You declare, what I've done is I've declared the method, but I am not I'm not providing implementation of the method, okay? I'm not going to, I'm only saying that this interface has a fly method, but I'm not telling the compiler how the fly method is going to execute, okay? I'm not providing the implementation, or I keep saying implementation. I don't know if that's going to make any sense to you, but what I'm trying to say is I haven't provided the code that tells the compiler how to execute this fly method, okay? That's the implementation of a method, okay? The code that you write that tells the compiler, okay, when this method is called, this is what you do. This, like the set of statements or group of statements that tell that the computer is supposed to execute whenever that method is called. That is the implementation of that method, okay? Now, an interface, the members of an interface, the public members, that's these ones. Like I told you, for now, just disregard the private members. I would say just disregard them as a beginner for now, because honestly, to me, I still have to go back and read a lot on why the private methods and their implementation are allowed in C#. I used to think they are completely not allowed, so it's surprising for me to see that they are allowed now. So for you, I would say just disregard them for now, and hopefully after what I read up, I'll try to put up another maybe tutorial later on and try to explain why they allowed the private methods in an interface. Okay, so this is how an interface is created. Okay, so this is now my interface. Remember, I said this is a method, right? This is a declaration of a method. Now, that is how an interface is created. You only declare the public method. You do not create the implementation for that method. Okay. Okay. Also, I think I also mentioned earlier that it's not necessarily only a single method. So what I mean is that we can have another method in here. So maybe a method that returns a value string, say let's say hello. Okay, and we put a semicolon. Okay, so these two methods now become the collection or the specification for this iFlyable interface. Okay, so I'll just go ahead and remove that. I just added this to show you that you can have as many methods declaration in your interfaces as you want. Okay, so for now I'll just remove that. Okay. All right. So this is our definition of our interface, our iFlyable interface, right? Now, next, what really do we try to achieve? There's a reason why I called it iFlyable, and there's a reason why it has a fly method. We'll see later. But just before we go back to our program.cs source file, let me just give a little explanation on why the convention, why it starts with an I and why it's ending with ABLE. Okay. Now, as I always say, conventions are only conventions. They are not. It's not like a dogmatic rule, like you have to do it this way. Okay. It's just a convention. Now, the convention that .NET uses is that every interface starts with a capital I. Okay. So you start with a capital I. So usually, if you in most of the types that you see in .NET, the moment you see a type starting with a capital I and then immediately followed by another capital letter, you kind of get a hint already that that is an interface, okay? Because that's the convention that they use in .NET. So it's the same convention. I also like using it. And for me, I also like adding an ABLE at the end of the name of my interface. Okay, so really this interface could have been named Fly, but because it's an interface, I add a capital I as prefix, and then as suffix I add an ABLE. Okay, and also it gives me, like, the moment I look at this name iFlyable, it gives me I don't know how to put it. It gives me this idea that whoever implements that, whatever class implements this interface, that class gives is flyable. Okay, like that class, the objects that come out of that class can fly. Okay, that's the kind of idea that this name gives me. That's why I like using this naming convention. Imagine if we say suppose I say, can I say a duck is a flyable object? You know, that's the kind of idea I get. So that's why I like using the ABLE suffix in my interfaces. Okay. Also, like I keep emphasizing, this is just a convention. There's nothing stopping you from naming this interface my stupid name interface. Okay. There's nothing wrong with calling your interface this. All right. It's just that at the end of the day, you might look at it and you would not even recognize that it's an interface. You'll be thinking, is it an interface or is it a class? Okay. But when you use the convention that .NET uses, the moment you see the identifier, the moment you see the identifier of the interface, you immediately get that hint that, oh, this is an interface. Okay. All right. Let's go back to our program.cs and we'll see. So that's all about this. Now, let me just explain what I'm trying to achieve with that interface. Okay. What I'm trying to get at is I want to give you like a practical example of using an interface. That's why I created that a flyable interface. Let's bring up Notepad. Okay. All right. So imagine we're creating a game. Okay. We're creating a game where the character, that's the main character, can say use different modes of different modes or different objects to traverse the world. Okay, to traverse the world. Okay, so we're like, just imagine we're trying to create a game. Okay, I always use game examples. I know. I love creating games, so please bear with me. Okay, I'm also it's sorry for those that are really not into games, and I know there are a lot of people that go into programming in the sense that they're trying to get at creating useful applications that help in day-to-day jobs. Really, I'm really sorry to those kind of programmers, because it's kind of tilted. Most of my examples are tilted towards the game programmers, so bear with me, please, if you're not really into games. Okay, back to our discussion. Okay, what we're trying to create is, I said we should imagine we're trying to create a game where the character can use different objects to traverse the world. That's to travel within the virtual world that we've created. Okay, so and the three different, suppose we have three different classes of objects that the current character can use. So we have, say, birds. Okay, so the character can climb on top of birds and traverse the virtual world. We also have dragons, and finally we have aeroplanes. Okay, aeroplanes. Okay, good. Now, we want a situation where if the character chooses any one of these objects, okay, if the character chooses any one of these objects, we want the character to be able to fly that object. Okay, suppose the character chooses a bird, and the character wants to go from point A to point B. We just want that character to be able to fly that bird. Okay, like he should be able to control the bird, like make it fly. Okay, now it means that this bird that's the bird class needs a fly method. Okay, the same thing with the dragon. Suppose if the character chooses a dragon object, the character should be able to fly that dragon. That means the dragon class also needs that fly method. Okay, of course, the way the bird is going to fly is going to be completely different with the way the dragon is going to fly, meaning the implementation, okay, the implementation of the fly method of the bird class is going to be different from the implementation of the fly method of the dragon class. The same thing with aeroplanes. If the character chooses an aeroplane, the way the aeroplane is going to fly should be different from the way dragons are going to fly, and different from the way birds are going to fly. Okay, the only thing common among them is that we all know the character needs to be able to fly those three different objects. Okay, good. Now, in our game, the easiest way to achieve such a setup, or such a feat, or such thing, is to simply create a interface, a flyable interface. Okay, so basically, well, not really a flyable, any interface, just create an interface. So we create an interface that contains the fly method. Okay, that contains fly method. All right, now when we create that interface that contains that fly method, right? We make this bird to implement that interface. We make the dragon class to implement that interface, and we also make the aeroplane class to implement that same interface. Now the three all implement the interface, whatever we call it. Suppose we call it iFlyable, okay? So we make the three different classes to implement the iFlyable interface, right? Now, when we do that, that gives us a particular type, okay? It gives us a particular type, and this particular type, remember the type I was saying in the previous lesson where I said you should always keep in mind that type exists, okay? That's the type I'm talking about here, okay? Now it creates, by creating that particular interface, it creates a kind of type that is common to these three different objects, okay, or three different classes, okay? Because now the problem you're going to run into, assuming you do not create that interface, is that you see the birds have their own class. The birds are going to have a bird class. The dragons are going to have a dragon class. The aeroplanes are going to have an aeroplane class, right? Now, suppose you want a variable to be stored or a field to be stored in the character class, which is going to signify, which is going to hold whatever the character is using as his means of transportation, right? Remember, C sharp is a how do I put it? It's is it naming? I can't remember the word. Anyway, it's before you can use a variable, you have to declare the variable. That's what I'm trying to say. I can't remember the word. There's a word for it. So C sharp mandates you to always say, before you use a variable, you have to say this variable is of type this, right? Is of type so so so. So if we need, suppose we need a variable, right? This is our problem. We need a variable that holds the object the character uses as means of transportation. Okay, so this is our whole problem. We need this variable, right? But notice something. To create this variable, we have to declare the variable, right? Now, the problem comes in, how do we declare this variable? Do we declare it as a bird? Or do we declare it as a dragon? Or do we declare it as an aeroplane? You will notice that none of these three is going to satisfy our condition. If we say we're going to declare it as a bird, right? It means that we will not be able to hold a dragon in this variable, right? And if we declare it, also we will not be able to hold an aeroplane in that variable. But ultimately, what we want to achieve is, we don't care whatever means of transport the character selects. We want that that particular means of transport to be held by that variable, right? So basically, we cannot declare it as a bird. So the bird type is wrong. We can't use that, because if we say we declare it as a bird, then we cannot hold a dragon nor an aeroplane. The same thing if we choose a dragon. If we declare it as a dragon, we cannot hold the variable cannot hold a bird or an aeroplane. You see the problem that comes in. Now, this is the whole reason why you need this iFlyable interface. Where is it? That's the whole reason why we need an iFlyable interface. So basically, what you need in order to solve that problem is you need a type common to those three different classes. In fact, not just the three different classes. You will later see that for an interface, it kind of keeps your possibilities open. So later on, if we decide to include jets, right? Because of the interface, it allows us to hold up to 4, right? And in fact, for using the interface, it gives us a type that is common to basically infinite classes. Okay, now which classes is are going to will the type be common to? The type will be common to whatever type of class that implements this iFlyable interface. I know I'm beginning to go too theoretical because we still haven't seen any code. Please bear with me. I'm just trying to explain to you the whole reason why you need an interface. Okay. In a short while, we're going to go in and write some code. Okay. So that's the whole reason why we need that interface. So the type we're going to need. So here, this variable, the type we're going to declare it as is, we're going to declare it as iFlyable. Okay, remember I said interfaces are a category of type. So you can actually use the iFlyable interface to declare that variable. So that variable, if you declare it as an iFlyable type, it means that that variable can hold birds, it can hold dragons, provided that birds implement the iFlyable interface, right? Also, it can hold dragons, provided dragons implement iFlyable interface. It will also be able to hold aeroplanes, provided aeroplanes implement the iFlyable interface. In fact, that variable is going to be able to hold any other class that implements iFlyable interface. Okay, that's not the spelling of iFlyable. Okay, all right. You see, this is the whole. I just hope you were able to understand what I'm trying to explain here. The whole reason why you need interfaces is because of this kind of problem. Okay. All right. Now let's go back to our. Already, I have explained what we're trying to achieve with that iFlyable interface. So let's go back to Visual Studio and let's try to implement that. Okay. I'm going to be very quick in writing the code, so please bear with me. Just the main thing is, if you understand my explanation here, I'm pretty sure you should be fine. Okay, if you're not fine, I'd suggest you read on, look for textbooks. There are so many good explanations on the net, in textbooks, even on Stack Overflow. Okay, you can always get good explanations, better than what I've given you here. Okay. All right, so in this project, I'm going to create the 3 different classes. So I'm going to add a class. I'm going to call this class birds. I'm going to call it bird. So this is the bird class I'm going to add. Okay, that's the bird class. I'm going to add another class, project add class. I'm going to add a dragon class. So dragon. So that's a dragon class. And then finally, I'm going to add one more class, the aeroplane class. So I'm going to add an aeroplane class. So we add. Okay, good. So we have our 3 different classes. We have the aeroplane class, the dragon class, and the bird class. And then finally, we have the iFlyable interface. Okay. Now, good. Remember, okay, let's just make these public. Okay, your classes should be public. Finally, the bird class should also be public. Good. Now we've created, okay, let's just file save all. We've created our 3 different classes for our modes of transportation for the character in our game, in our hypothetical game. The next thing you need to know is, if you create your class this way, all you've done is you've just created the bird class. Okay, the bird class as it is now does not implement the iFlyable interface. Okay, to make the bird class implement a flyable interface, what you need to do is, after writing the bird, you just give a space and then you put a colon, okay, and then you write the name of the interface that the bird class implements. Now that is the iFlyable. Okay. Now notice one thing I would like to tell you is that you can actually have, notice this is just one interface, right? We can actually create more than one interface, right? It also means that if you want your class, for example, this bird class can actually implement more than one interface. And the way you do it is, after the colon, you put the first interface, then you use a comma, you add the second interface. So suppose I have another interface called say walkable, you add it there, okay? And if you have another interface that is implemented, you add a comma, you keep adding the interface, but after the last one, you do not use a semicolon, okay? You just leave it that way. Okay? So let's remove this, and we're going to remove the comma because the iFlyable is the only interface. We don't want any other interface. Good. Now notice what happens if you say the bird class implements iFlyable interface. Immediately you get a red a red mark telling you that there's something wrong with your bird class. Okay, notice what it's saying: bird does not implement interface member iFlyable.fly. Okay, what it's saying is that, okay, you said that the bird implements iFlyable interface, but you have not provided the implementation of this fly method. Look at the iFlyable interface. It has a fly method, okay? Now, that is the thing you need to know about classes implementing an interface. Interfaces are they're like contracts, okay? If you sign a contract, right, like the law mandates you to satisfy the terms and agreement of that contract, okay? Now think of the law in this our programming context as our compiler, right? The compiler mandates you because you have said that you agree to the iFlyable interface, this contract. It means that every member that is inside this iFlyable interface, you have to implement it. That's every public member, okay? That's why forget about the private members. Don't let it confuse you. Like I said, I'll talk about them later when I read up on them. So every public member of the iFlyable interface must be implemented inside your class. Notice that in the iFlyable interface, the implementation of the fly method was not provided, okay? It's saying usually when you create an interface, you do not provide the implementation. You're saying whoever implements this interface is going to be responsible for providing the implementation of this fly method, okay? So for the bird class, we'll need, that's why we're getting this red underline. So to make that go away, we have to make sure that the bird class satisfies the terms and conditions of this iFlyable contract. Okay, so remember we said interfaces are like contracts. They are like binding contracts. Since we agree to the terms, we have to provide the implementation for the fly method. So we have to say public, and notice the signature of the method has to be exactly the same way as the signature of this, okay? So we're going to say public void fly, and then we open the normal curly bracket. Notice we are not using a semicolon here because that's a declaration, okay? We are not declaring. Here we have to provide the implementation, okay? And then just for visual sake, to be able to see our output when we run this program, I'm going to write some code here. So I'll just say console.writeLine. So this is just how the bird flies. The bird is going to say something like flappity, flappity, flap, flap, flap. Okay, so that's just like flapping its wings. Okay, all right. So flappity flappity flap flap flap. That's how the bird flies. Okay, that's how we decide to implement the fly method of the bird class. Okay, next we're going to so we have satisfied the condition. You can see that the red line has gone away. We have satisfied the condition of this bird class implementing this iFlyable interface. Okay, and that's all for now for the bird class. Let's go ahead and do the same thing for the dragon class. We have to say the dragon class implements the iFlyable interface, and in here we're going to create the fly method, public void. Because it says it implements the iFlyable, it has to satisfy that contract. Now notice, this is where I really want you to notice the difference. Now remember, the implementation of the fly method in the bird class. Notice the way it is. This is how it was implemented. These things I'm writing in here is just to show you that the implementation, that's the code you write in here, are supposed to be, well, they can be whatever you want. They can be different. So the fly method of the dragon class is going to differ from the fly method of the bird class. Okay, because the way the dragon flies obviously is different from the way the bird flies. Okay, so for the dragon, we're going to say console.writeLine we'll say glide, sorry, not that, glide fire, glide, sorry, glide fire, glide fire. Okay, so that's how the dragon flies. Okay, so if we tell the dragon to fly, this is how it's going to fly. It's going to glide, then it's going to breathe fire, then it's going to glide, then it's going to breathe fire, then it's going to glide, and then it's going to breathe fire. Okay, all right, I'll just go ahead and file save all. Finally, we're going to provide the implementation. Okay, first we have to say the aeroplane class implements the iFlyable interface, and then in here we have to provide the implementation of the fly method. So public void fly, and we'll just say the way the aeroplane flies is console.writeLine we'll say boring engine sound, and that's how the aeroplane flies. Okay. That's the three different classes. Okay, so we've created the three different classes: the aeroplane class, the dragon class, the bird class, right? And we've created the iFlyable interface. Also remember that these are not yet objects, these are classes. Okay, the aeroplane class is a class, it's not an object. Okay, don't forget that. We can use this aeroplane class to create as many aeroplane objects as we want. Okay, so we're going to go back to our program class, and in here should we create a character class? I think we should. Maybe not necessarily. Let's not detour too much from, let's just focus on the main thing where we're just trying to explain the iFlyable. So let's not create a character class. Instead, what we're going to do is we're just going to create the means of transportation here. So remember that variable I said in my explanation. I said the whole problem is about creating a variable that holds the object the character uses as means of transportation. So suppose we're going to say the identifier for that variable is say let's call it mode of transport, right? Let's call it mode of transport. So that is the name of the variable. Remember, to declare a variable you have to specify its type. Okay, By the way, this is the whole point I was trying to make here when I was explaining. Notice that if we say we're going to declare this as a bird, right? If we say we're going to declare this as a bird, right? It means that we cannot say mode of transport is equal to new aeroplane. That's we're creating an aeroplane object. You see, this is not going to work. The reason is because the type of this variable is bird, right? Oh, sorry about that. The type of this variable is bird. The same thing, if we say we're going to declare it as a dragon, then we would not, of course, we can say mode of transport is equal to new bird here. Notice that it's going to work because the variable, the type of this variable is bird. So it allows you to store a bird inside mode of transport, okay? But you cannot store any other type of object if not a bird. So we cannot store a new dragon here, right? See, you can't do that. And that's the whole reason why we needed this interface in the first place, okay? So we want a variable that allows us to hold either a, not this again. Okay, remind me tomorrow. Tomorrow I'll say remind me the next tomorrow. Okay, so that's the whole reason why we created the iFlyable interface. So now notice what we're going to do here. We're going to say iFlyable. So the type of the variable is iFlyable, okay? So we're saying iFlyable mode of transport. Now notice what happens. I can say mode of transport is equal to new dragon, right? I can at the same time say mode of transport is equal to new bird, right? It accepts it. I can also say mode of transport is equal to new aeroplane, right? It accepts it. Imagine our code later on in our game. Maybe some players of our game begin to disturb us. Oh, please, we need a new type of mode of transportation. We want jets, right? Just like whenever I look at Ed Boon's Twitter page, people are always flooding him with requests of Melina and of let's not go there, okay? All right, okay. So that's the whole point of using the iFlyable interface. It gives you it not just for these three different classes. You can have in the future, you can have more classes that you can still easily implement in your game, right? And you don't need to change the code. The iFlyable interface remains the same. All you need to do is just the new the new class that's the jet class. If I want to create a new jet class to add to this game, I just create the jet class, right? I don't need to change any code in the already existing code base, okay? So that's really the whole use of the of an interface, okay? So let's just go ahead and finish this. So let's say iFlyable mode of transport is equal to new aeroplane, and then notice just before we end the program, we're going to say mode of transport dot fly. Notice that we can do this. We can call mode of transport dot fly, right? Now, when we call mode of transport dot fly, it's going to depend on whatever type of object is stored inside mode of. If a bird is stored inside mode of transport, you will see that it will fly like a bird. If an aeroplane is stored inside mode of transport, you will see that it flies like an aeroplane. And if a dragon is stored inside mode of transport, you will see that it flies like a dragon, okay? So let's go ahead and run this program. At the moment, we made a new an aeroplane object, so we expect to see it flying like an aeroplane, okay? So let's run this program. And what do we see? Yes, boring engine sound. All right, so you can see it's working fine. By the way, just to prove my point, I'm going to change this to bird. And notice if we run this program now, we will see that it goes flappity, flappity, flap, flap, flap. So it flies like a bird. And if we change this to aeroplane, sorry, we've done that. if we change it to dragon, you will see that it flies like a dragon. So it goes glide, fire, glide, fire, glide, fire. Okay. So I hope this class was able to show you the usefulness of interfaces. How well the most important thing is how interfaces are created, how to implement. Don't forget how to implement an interface. You use a colon and then followed by the name of the interface, and then finally how you satisfy the condition. Whenever you implement an interface, you are expected to satisfy the conditions imposed by that interface. Okay, so imagine if this interface had two different methods: public void fly and public void walk. If we add a public void walk here, by the way, let's go ahead and do that. Public void walk. Notice that it means that we have to update all the classes that implement that interface. You see, the bird class says it implements a flyable interface, but this interface has two methods, a fly and a walk. It means that these are the two terms and conditions of this contract. So whenever a class implements this interface, it must make sure that it is mandated to always provide implementations of fly and implementations of walk. So if we say this interface contains fly and walk, it means that every class that implements the interface, like a bird class that implements it, has to have a public void fly and a public void walk. Okay, and when you do that, you will see that the red line goes away. Okay, so let's just remove that. I just put that to give you further explanation. Okay, so that's what an interface is. I hope you were able to understand at least how to create interfaces and how to implement them. So I'll see you in the next class.